So let's just start with the biggest question of all, right? The one that fuels everything from sci-fi movies to the most advanced research labs. How do machines actually think? I mean, it sounds like a simple question, but trust me, the answer is going to take us to some pretty deep, pretty fascinating places.
And see, that's the thing. The moment you ask how a machine thinks, you run smack into an even bigger, even trickier question. Because how can we even start to build a thinking machine if we can't agree on what it actually means to think in the first place?
You know, back in the early days of AI, the pioneers trying to solve this didn't agree on one path. They actually tackled this from two totally different directions. You could almost say they drafted two competing blueprints for how to build an artificial mind. Okay, so on one side, you've got what's called symbolic AI. We can just call it the rulebook. This is a top-down approach. Just imagine you're teaching a computer chess by manually programming in every single rule, every possible strategy. It's super precise, right? You can follow its logic step by step. And for a long time, this was the way to build smart systems. But then there's the other approach, connectionism, or the learning brain. And this is the complete opposite. It's bottom up. Instead of feeding it rules, you just show it a massive amount of data, like thousands and thousands of chess games, and you just let it figure out the winning patterns all by itself.
Now, both of these ideas had their fans, for sure, but, well, one of them pretty clearly won out. That learning brain model, yeah, that's the one that powers basically all the AI you and I use today. So let's pop the hood and take a look at the engine that makes it all work, the neural network.
Okay, now, the mechanics here can get super complex. I'm talking heavy math and code. But the core idea? It's actually kind of beautiful and really simple. And probably the best way to get it is to just forget about all the tech for a second. Let's just think about a little kid learning how to recognize a cat.
So, step one, you just show the network a ton of data. In this case, thousands and thousands of cat pictures. Then, the network starts to look at all these images and find patterns all on its own. You know, common things like pointy ears, whiskers, a certain kind of tail. Based on all those patterns it's seeing, it'll make a guess. It'll say, hey, I think that's a cat. Now, here's where the real magic happens. If it's wrong, it goes back and adjusts its own internal wiring, basically strengthening the connections that would have led to the right answer. It literally learns from its mistakes, and it does this over and over millions of times until it gets ridiculously good at spotting cats.
And look, this process is just astonishingly effective. But it brings us right back to that big philosophical question from the beginning, doesn't it? Is this machine, this amazing pattern recognizer, does it actually understand what a cat is? You know, the furry thing that purrs and knocks stuff off your desk? Or is it just doing a really convincing impression?
There's this famous thought experiment that really gets to the core of this whole debate. It's called the Chinese room argument. Okay, picture this. You are locked in a room and you don't speak a single word of Chinese. Now, someone slides a piece of paper with a question in Chinese under the door. But you have this giant rule book. And this book tells you exactly which Chinese symbols to write down in response to the symbols you were given. So you follow the rules, write down the answer, and slide it back out. To the person on the other side of the door, it looks like you're totally fluent. But do you actually understand any of it? Not a word. You're just matching symbols. You're just following the rule book.
And that was the point from the philosopher John Searle. He argued that just because you get the perfect output, that doesn't prove there's any real understanding going on. There might be, well, nothing going on inside the box. And that's the huge question we're facing now. Is modern AI just a super advanced version of that Chinese room? Is it just manipulating data without ever truly comprehending what any of it means?
This isn't just a fun little puzzle for philosophers either. This is the fundamental challenge at the very heart of AI research today. Because as these systems get more and more powerful, figuring out where that line is, the line between just processing data and actually understanding it, that becomes the next great frontier. And getting this right, it's not just academic. It affects everything, from AI safety, making sure these things do what we expect them to do, to figuring out if an AI could ever be truly, genuinely creative.
Okay, so let's wrap up with the key takeaways here. What do we learn? First, just the idea of thinking is way more complicated than it sounds. Second, we saw how AI's architects had to choose between two very different paths, the top-down rulebook or the bottom-up learning brain. Third, modern AI is absolutely brilliant at that learning brain approach, at recognizing patterns. And finally, all of this leaves us with that one deep philosophical question still hanging in the air. Is it true understanding, or is it just an incredibly perfect act of mimicry?
And I guess that leaves us with one final kind of mind-bending question to chew on. If a machine's thought process becomes so advanced, so perfect, that we literally can't tell it apart from a human's, if its reasoning, its art, its conversation are completely indistinguishable from our own, does the difference still matter? Does it matter what's actually happening on the inside if the outside is perfect? Something to think about. Thanks so much for joining me on this one.